Hello everybody and welcome to Module 10, Monster Paper 4. This is question 2. So it says some elements are shown in the order they appear in the reactivity series. The most reactive element is at the top. So I would just write most and least here just to remind myself, but we do know that sodium as a group 1 is obviously way more reactive than copper, which is down the bottom. So identify the non-metal. Well, all of these are metals. The only two non-metals that appear in the reactivity series are hydrogen and carbon. And so we haven't got carbon here. So the non-metal that they're talking about is hydrogen. Now, it's worth noting here, because they've given you the answers in words, you're allowed to write the words on the exam paper. If they've given you them in symbols, you should copy them over in symbols. But if they've given the words, it's much easier. If you start writing symbols and showing off to the examiner, oh, it's okay, I know that sodium is Na and calcium is Ca, then yes, great, you're smart, but you're not getting any extra marks for it, and you are much more likely in the pressure of an exam to make a mistake. So if you're allowed to use words, always use words. A metal which is stored under oil, well, of course, that's going to be the most reactive one. Only the group 1 metals are stored under oil, so we're going to go for sodium. The main component of steel, well, steel is made from pig iron from the blast furnace, so it must be iron. A metal with 3 electrons in the outermost shell. 3 electrons would mean that it's in group 3. So even if you didn't remember which group each metal was in, you've always got your periodic table. So you know if it's got 3 electrons in group 3, well, that would be aluminium. A metal found in brass is, of course, you can have either zinc or copper. It doesn't matter. Both would be fine. So in this case, I'm going to go for copper because I like to remember that brass is the same color really as copper. It gets its color from copper. So it's a copper color. And a metal that forms chlorides of the type XCl2 and XCl3. So it would have to be something that existed as a +2 ion, and also a +3 ion. So we know we're looking at a transition metal, so it can't be sodium, it can't be calcium, it can't be magnesium. Aluminium is always a +3 only. Zinc exists as a +2, but even if you didn't know that and you didn't remember that, the only transition metals, the only 3 transition metals are these 3. Copper and zinc tend to exist as +2 only. And don't forget as well that iron, when we're testing for ions, we know that iron exists as a +2 and a +3 because we remember the colors. The +2 is green and the +3 is brown. So here we are talking about iron, has to be. Next part. Name the main ores of zinc and aluminium. Well, the great thing is that this is an old question. You don't need to know in the current syllabus as of examination in 2024, you do not need to know the process of extracting zinc. But in this case, I'll tell you anyway, it is zinc blend, but you don't need to remember that for this syllabus. That's an old question. Aluminium is, of course, made by bauxite. The only 2 processes that you need to remember is the extraction of aluminium from bauxite and the extraction of iron from hematite. In an experiment, a sample of aluminium appeared less reactive than expected. They love to ask this question. It is a really common exam question, and it's always just a really easy mark. We know that aluminium forms, so we'll start with it. Actually, it is a banned word, remember. We don't assume that the examiner knows what we mean when we say it, so we are going to write aluminium, even though you could probably get away with it in this case. But we're going to be specific. We're going to abide by our it is a banned word. Aluminium forms a protective oxide layer. And what happens is it reacts with the oxygen in the air very rapidly, and then that oxide layer is very, very stable. And so it actually protects the aluminium with a layer of aluminium oxide. So the aluminium inside doesn't actually react any further, which makes it appear less reactive than we would expect because it's quite high up the reactivity series. Name 2 metals from the list which are extracted by reduction of their ores using carbon. Well, therefore, it would have to be something that is lower than carbon in the reactivity series. So, where does carbon fall? Please stop lying and calling me a cute zebra. Cute is carbon. So it could be zinc, it could be iron, or it could be copper. You can have any one of the three. So name 2 metals. We're going to go for zinc and iron. When zinc granules are added to aqueous copper 2 sulfate, a reaction occurs. During the reaction, a red-pink solid is formed and the solution becomes colorless. Name the red-pink solid. Well, the zinc is more reactive than the copper. So the zinc is going to come and displace the copper from the sulfate. So you're going to end up with zinc plus the copper sulfate makes copper and zinc sulfate, because the zinc is more reactive, so it's going to come in and steal the sulfate. So the red-pink solid must be copper, and the colorless solution, the only thing left, is zinc sulfate. There you go. Explain in terms of particles why the rate of this reaction increases when the temperature is increased. And you'll see that it's 3 marks. So that means you need to have 3 bullet points at the very minimum. So in this case, anything when we're talking about rate of reaction and temperature, we know that we're going to start, the first mark is going to say something along the lines of more heat equals particles have more energy. That's our first mark. Then we're going to say that because they have more energy, there are more collisions between particles. Probably a better use would be to say more frequent. So we're talking about the collision frequency. But also, when they collide more often, they're also colliding with more energy. So we're going to say words like more of the collisions happen at or above the activation energy. Remember, in order to actually have a successful chemical reaction, particles need to collide at the correct orientation and at or above their activation energy. So whenever they're talking about temperature, there is always 2 reasons why the rate of reaction is increased. It's more frequent collisions, and all of the collisions that happen have more energy. Suggest 2 other ways of increasing the rate of this reaction. Well, there are many ways that we could increase the rate of reaction that we learned about in our energy module. So we could use a catalyst. We could also increase the surface area. Another thing that we could do is increase the concentration. So here we've got zinc granules. So if we made it powder instead of granules, or if we just use smaller granules, that would increase the rate of reaction. But we've also got aqueous, something that's a liquid here. So we've got an aqueous thing. If we've got aqueous copper sulfate, if we increased the concentration of the copper sulfate, then we are going to actually increase the amount of copper sulfate, or the number of particles of copper sulfate. So a third one, if you didn't like these 2, would be, so if we say increase the surface area of the zinc, and then we could just put powder here. And if you didn't like any of those 2, another alternative that would have gotten you the mark is increase the concentration of the copper sulfate. Now, again, you may know that copper sulfate is CuSO4. If you are absolutely confident of CuSO4, then you can write CuSO4. You're not going to get marked down. You don't have to write it in full. But as it's given you the words up here, if you introduce copper sulfate as CuSO4, and you accidentally make a mistake and you say something like copper sulfate, you're stressed in the exam and you say copper sulfate, then you just negated that whole mark. So there's no point in taking a risk that you don't have to take. If you know it's copper sulfate, you're not getting any extra kudos from the examiner by writing CuSO4, although it is quicker to write if you're very, very confident. Okay, so that's question 2. Hope it was helpful.